All right, let's talk about the single biggest, most violent explosions the universe has to offer. Gamma ray bursts. I mean, these things are the most powerful events since the Big Bang itself, and they happen all the time, just, usually very, very far away from us. So let's dive in.
And that is not an exaggeration. That's what the scientists who actually study these things call them. We are talking about events so mind-bogglingly powerful, they can outshine billions of galaxies all at once. They really are, quite literally, energy monsters.
And that really is the million-dollar question, isn't it? We see these cosmic fireworks going off in the distant universe all the time. But what if one of those monsters turned its gaze toward us? What would actually happen if the universe took a potshot at Earth?
To really get the threat here, you have to stop thinking of it like a bomb going off in all directions. It's much more like a sniper. The energy isn't just a big sphere of destruction. It's focused into two incredibly narrow, terrifyingly powerful beams. And if Earth just happens to be in the crosshairs, well, the consequences would be absolutely catastrophic.
Okay, so here's the crucial part. You wouldn't be vaporized on the ground. Our atmosphere is actually an amazing radiation shield. The real danger is way more sneaky than that. The blast of energy would trigger a chemical chain reaction high up in the stratosphere, basically waging chemical warfare on the very air that keeps us alive.
So this is how that chemical warfare plays out. The gamma rays hit the upper atmosphere and just smash nitrogen and oxygen molecules apart. This creates this nasty cloud of nitrogen oxides. And what do? They act like catalysts, just shredding our ozone layer. We're talking about a global depletion of almost 40%, and it would last for years. This lets in a flood of deadly UV radiation from our own sun, cranking up DNA damage on the surface by a factor of 16. And to top it all off, that new nitrogen dioxide creates a brown smog that blocks sunlight, potentially kicking off a rapid cosmic winter. It's a devastating 1-2 punch for life on Earth.
So we know the threat is very real, but to really get a handle on the risk, we need to understand the monster itself. What in the world is a gamma ray burst?
Well, officially, it's the brightest kind of explosion we've ever seen, period. They were actually discovered by accident back in the 60s, by satellites that were looking for secret nuclear bomb tests. For decades, we had no idea where they were coming from. Now we know they come from the absolute farthest reaches of the cosmos.
This number is, well, it's basically incomprehensible. This is the energy that was released by the most powerful GRB ever seen, one back in 2022 that got nicknamed the Boat, for brightest of all time. Now, an erg is a tiny unit of energy. Think of a mosquito doing a single push-up. But you're looking at a 1 with 55 zeros after it. For perspective, a typical supernova, an exploding star, releases about 10 to the 51st ergs. The Boat was 10,000 times more powerful than that.
And this, right here, just perfectly illustrates the insane intensity we're talking about. A typical gamma ray burst unleashes as much energy in a few seconds as our own sun will produce over its entire 10 billion year life. All that energy, from a star's birth to its death, all of it let loose in the time it takes to snap your fingers.
Now, an explosion that powerful obviously needs an equally powerful trigger. So how do you even build one of these cosmic cannons? Well, it turns out there are two main recipes for destruction.
Scientists basically split them up by how long they last. You've got your long bursts, anything over 2 seconds, which come from the death of a single, enormous, rapidly spinning star. Then you have the short bursts, which are quicker than 2 seconds. We think those are caused by the violent collision of two superdense objects, like a pair of neutron stars. Let's take a quick look at how each of these cosmic recipes works.
Okay, so for a long GRB, you start with a star that's at least 30 times bigger than our sun. When it finally runs out of fuel, its core collapses straight into a black hole. But because the star is spinning like crazy, all the matter falling in forms a swirling disk. That disk powers up two incredibly focused jets of plasma that blast out from the poles at almost the speed of light. Now here's the catch. If those jets manage to punch their way out of the rest of the star, that's when we see a GRB. The recipe for a short burst is just as nuts. You take two neutron stars. These are the collapsed, dead cores of old stars, and you lock them in a death spiral. As they orbit each other, they shed energy as gravitational waves, which causes them to spiral closer and closer together. The final collision is just cataclysmic. It forges a new black hole and launches a quick but just as powerful burst of gamma rays. And we know this happens. We confirmed it in 2017 when we detected both gravitational waves and a GRB from the exact same event.
So this isn't all just theory. There's a whole bunch of evidence that Earth might have already been on the receiving end of one of these celestial sniper shots. The prime suspect? The very first of the Big Five mass extinctions, a 440-million-year-old cold case.
Yeah, the Late Ordovician mass extinction has always been a weird one for paleontologists. It happened in 2 sharp pulses, and it involved this sudden, dramatic ice age that just didn't seem to make sense with the climate at the time. But when you start looking at the evidence through the lens of a gamma-ray burst, the pieces really start to click into place.
Just look at the clues. First, the extinction pattern. It was the creatures living in shallow water, things like trilobites, that got absolutely hammered. Deep sea species, mostly fine. That's exactly what you'd expect if the killer was a blast of UV radiation, because water is a great shield. Second, that sudden ice age. A GRB would create that sun-blocking smog we talked about, giving you a perfect trigger for rapid global cooling. Now, there's no smoking gun, but the circumstantial evidence, it's pretty compelling.
And that brings the threat much, much closer to home. If it happened once, could it happen again? Are there any of these potential cosmic time bombs lurking in our own galactic backyard? And the answer, of course, is yes.
Astronomers are keeping a very close eye on several massive, unstable star systems right here in the Milky Way. You've got systems like Eta Carinae, this massively unstable giant that's considered a ticking time bomb. But there are 2 in particular that have really interesting stories. WR104, which gave us a bit of a scare, and a really bizarre system nicknamed Ape.
For years, our #1 suspect was a system called WR104. It's a type of massive, hot, unstable star that's the perfect candidate for a long GRB. And when we looked at it, we saw this gorgeous pinwheel of dust spiraling out from it. The problem? The pinwheel looked like it was perfectly face-on to us, which meant we were staring straight down the barrel of the star's rotational axis, the exact path a GRB jet would take.
But thankfully, more recent and precise measurements brought a huge sigh of relief from the astronomy community. By looking really closely at the system, scientists figured out that the actual axis is tilted about 40 degrees away from us. So while the dust looks like a target, the cannon itself is pointed safely off to the side. We dodged a cosmic bullet we never even knew was coming.
Which brings us to Apep. Named after the Egyptian god of chaos, this system is a real weirdo. It's got a pair of massive stars, and crucially, one of them is spinning so fast it's on the verge of tearing itself apart. That extreme rotation is the key ingredient you need to launch a powerful GRB jet. Now, its axis isn't pointed at us either, but it is the first perfect GRB candidate we've ever found right here in our own galaxy.
When it comes right down to it, the story of gamma-ray bursts is really a story of cosmic chance. We live in a universe full of these celestial snipers, but their beams are incredibly narrow, and the galaxy is just unbelievably vast. Our safety is, in the end, a matter of geometry and pure luck. For now, we seem to be safe, but as we keep watching the heavens, it just makes you wonder, what other secrets are still waiting out there in the dark?